Edexcel Core Pure, second order differential equations 3, modelling with second order differential equations, finding particular solutions. We've seen in a previous video how that we can solve a pair of first order simultaneous differential equations using methods used to solve second order differential equations. So for example, if this is our first order equation for dx by dt and this is our first order equation for dy by dt, we found that we could form their general solutions in the form y equals a plus b e to the 2t and x equals a minus b e to the 2t. If we are now given some other information about the values of x and y at a particular time t, we can attempt to find the constants a and b and therefore find the particular solutions. So now we're told that initially x is 1 and y was 3. So in our example, that's saying initially there was 1 fox and there were 3 rabbits. So let's see if we can use those initial conditions to find the particular solutions. So starting with t is 0, x equals 1, subbing those straight into our first equation, we get 1 equals a minus b. And we're also told that when t is 0, x is 3, subbing those in, we get 3 equals a plus b. And if we solve these simultaneously, we get a is 2, b is 1. So we now have particular solutions to the problem, and those are x equals 2 minus e to the 2t and y equals 2 plus e to the 2t. Don't forget x and y are the dependent variables and t is the independent variable. So we used the fact that initially there was 1 fox, in other words x was 1, to form this equation, and initially there were 3 rabbits, so y was 3, to form the second equation. Once we've found a and b, we have the particular solutions for x and y. In the next video we're going to be looking at simultaneous differential equations and plotting and interpreting their solutions.